We are alive. We are alive. Good. How are we doing? So, welcome back. Stream. Yes. So we're going to be doing some maths. So today we're going to be focusing on the proof and algebraic functions topics. So I want to do a bit of both. We'll see how far we go. So first of all, I have to do the tedious task of arranging you, yes you, in such a way that you can see my piece of paper that I'm going to be working on. So I'll just try to stuck my paper together so it doesn't fall apart. So hopefully that works. Anyway, let's get this open and get the cable sorted. There we go. Okay, now we bring this a bit closer to us. We bring this like so, like so, like so. Oh. Now it wants to tilt. That's no good. We cannot allow that, can we? Look. Okay, technical difficulties for a second, but no need to worry. I just need to figure out why it wants to tilt. Okay, let's move this here. Still a bit unstable. Let's just put a pencil case on it and quick fix. There we go, done. So let's tilt it so you can see what's down here, and like so. And now that will allow you to see what I'm doing, while also blinding me because it's quite bright. That's good. Okay. So let's go into the desk view so you can see a bit more, and let's just double check that the stream is good. Desk view so you can see a bit more. Okay, all good. So proof and algebraic functions. Let's put this sheet away for now. And let's get going with this. So we've done proof 101 last time. Oh, actually, need to log in, don't we? Yes. Ah, madness. Remember me? Okay, let me log in. This one, yes, please, no. For God's sake. No worries. It's not like trying to do a live stream or anything. Yeah, no worries at all. Come on. Obviously it's the last one that works. I hate you. I hate this login. For the moment at least. I hate it with all of my being right now. For it being annoying. leave me the hell alone. I just want to go back to where I was. Oh. Here we go. All calm, all good. So, where were we? Proof 101. We have done this. Yes. So, my idea is to, we can leave this for now. I'll do the easy proof by contradiction one, then move on to algebraic functions, and possibly come back to doing the medium proof and medium difficulty proof by contradictions ones afterwards. We'll do the easy ones first and re-jog our memory after. Okay? So, first question, let me turn the light a bit towards me. Find the prime factors of the following numbers. Okay? So, we are looking for the prime factors. This is proof by contradiction. I'll just see how I've done it on the other one. Yeah, so just for easy questions because it will. I'll write proof by contradiction and then write easy questions afterwards, yes. Underline that. And let's get on with the question. So, question 1, and we have I. So, find the prime factorization of the following numbers. Prime factorization. So, well, prime factorization, so it's factors. So what makes it up? So you have, how do you do this again? Well, I know you could do it just by the easy way, but I know there's another way, because you could do like 1 and 100 and then 2 and I'll do the easy way and I'll see what it recommends. 250 3 no 4, so that would be 80 and then no, yes, 4 can, because 80 and then 20, so 4 times, I'm going to get my calculator out, just so I don't mess up on silly questions like these. Yeah, so 4 and 25. 25, 5 and 20, 6, no, 7, no, 8, No, you can't do 8, you can only do 4, 9, 10, and 10, and then you can do 12. You can't do 12, can you? 12, nope. 15, 20, no, and then you're back at the start. So I'm not certain if I'm doing it right, but for me the factors are 1, 2, 4, 5, 10, 20, 25, 50, 100. But no, so let's look at this because I'm not certain if I'm doing this right. Oh, prime factors. Oh, I remember this tree. Yeah, I knew it was something along the lines of this. Prime factors, prime factors. Okay, well, let's scrap this. I didn't really look at it too much. I know I went wrong somewhere, so I'll mark this as red because I didn't realize I was looking for prime factors. Just I was thinking I was doing proof by contradiction, not prime factors, but maybe it links somehow. So let's do it with this pen. But at least I will know that. Or if I get all of these right with the blue pen, then I will make as I'm not. What's this one? Unsure, because if I know the process, I just didn't read the question properly, then I know that I can do it. I just need to focus a bit more. To be honest, it is quite late, and I probably shouldn't be doing this late at night, but hey ho, this one I got time. So 100 can turn into 10 and 10, I guess. Yep, 10 and 10, and then that can turn into 2 and 5 and 2 and 5, which are all prime numbers. So 100 equals to 2 squared times 5 squared, and for part II it's 120. 120, that is 20, and that is 20, 40, 60, yeah, so 6. I don't know how to do the maths right now. I'm tired. God. 10, 2, 2, 5, and 2, 3, and 120 is 2 to the power 3 times 3 times 5. Let's see. View, and 2 to the power 2, 2 to the power 5 to the power 2, and 2 to the power 3, 3 and 5. So I knew what I had to do, I just didn't read properly. Let's see what it says. For prime factors, factorization is used to prove infinite number of primes. Infinite number of primes. Separating the factors until only factors are prime. That doesn't make too much sense, but I kind of get what it means. So I'll leave that as unsure and go on to the next one. But yeah, I won't take it because it's the actual right answer. But yeah. So that one, how many marks was this one? Question 1 was 4 marks. Oh yeah, 0 out of 4. Sad times. State whether the following are rationals or irrational quantities. For those that are rational, write them in the form AB, where A and B are integers and A over B is in its simplest term. So let us see. So it needs to be integers. Question 2. Let's see. Well, I don't see how. Let me just see how much you guys can actually see. I can see everything. Root 2. S. Yeah, I don't think that's rational. Another 3. I think that is. So the natural log one, yeah, is I think that. So I don't think this is rational. The first one. Second one, I think it is, but I don't know why or how to. I think it could be something on the lines of like 3 over root. I don't know. Just for the sake of I won't write it down, but I'll say that it's not rational. And this one, 4 root 2 over root 18 equals to 4 root 2 over, let's see, root, so that is 9 and 2. 9 times 2, which turns into 4 root 2 over 3 root 2, which equals to 4 over 3, which is rational. And the last one, wait, 3 ln 2 over ln, so that is 3 ln 2 over, no, I just tell this, 3 ln 2 over ln 32, which turns into ln 2 to the power, no, because 3 over 2, and I need to see how many, because I need to have ln 2 over here, so I can just have the number by itself. So let's delete all of this and let's do this, and let's root 32 by 3. Nope. 4, 5. There we go. So that is 5 ln 2, which consequently turns into 3 over 5. But then the thing is for something to be rational, does it not have to have a smaller like numerator to denominator? So like the top one needs to be smaller than the bottom one. I'm not certain. This is definitely rational. Okay, let's have a look. Oh, for God's sake. That's rational or rational or integers. And these are rational. Okay, so root 2 is rational, and ln 3 is irrational, not irrational, irrational. I'm a bit confused now, to be honest. These two are rational. Or no, stupid. No. I was wrong the first time, because these two are not rational, so they're irrational. I just didn't really read it properly, because it's... Yeah, so this is not rational, so no, this is right. So, I've done this wrong because I said this is not rational. This one is... I wasn't sure, but it's not rational. This one is rational, and this one is rational, because I've solved it both. So, come on, let's win. I've got 3 right, I didn't know this one, and that's not rational, so irrational, which means I've done 3 out of 4. And I'll say that I got it. What does it say? Got it, yes, got it. Because I did get it. I wasn't 100% certain about the second one, but I basically got it. So, question 3. Prove by contradiction that the sum of 2 consecutive integers are odd. So I have to contradict it, so sum of 2 consecutive integers are odd. So let's have n and n plus 1 whatever consecutive integers. The sum, prove by contradiction the sum, so that's adding them. So n plus, so n plus 1 adds together to equal 2n plus 1. Therefore, any multiplied by 2 is an even number and even that you add an odd number to odd. So it will always be an odd number. Full stop. So, just go over and n plus 1 are consecutive integers, right? Yeah, add these two together, that gives you, so because it's a sum, 2n plus 1. If you times anything by 2, it's going to give you an even number. And if you add 1, add any even number, and any even number that you add an odd number to becomes odd. So, because you add an odd number to an even number, it becomes an odd number. So it will always be an odd number. Let's have a look. Okay, so and following on, set up a consecutive number. Assuming the sum of two consecutive integers is even and can be written in the form 2k where k is are integers. I don't think I needed to put this down, though. I know. No, I'll say I think because I put consecutive integers, I think that just like hits the nail on the head. Let two consecutive integers be n, and then put, I didn't even know that they were going to use this, but they used exactly what I used, so that's good. I must be smart. So n and n plus 1. The following would be 2n plus 1. 2n plus 1 is odd and not even as assumed. The sum of two consecutive numbers is odd. I've said that, but in a long-winded way. So I'll give myself the marks because I've done everything, but I'll do an even better if the sum of two consecutive, therefore is odd. So my handwriting is not amazing today, but basically so just copy that down. That's got it. Next, prove by contradiction that the product of two numbers is odd. Two odd numbers is odd. Kidding me. Let's sit down. Need a bit of a rest. I'm being a bit today, and I feel like it's been nice to sit down for a second. Okay. So now it's delights in my eyes, you know. If I move this a bit this way and this, can't move any further, can I? Can move it like this, I guess. I guess. Now I'll have to. Okay, so I've actually just been on a 6.5 kilometer run, which was quite tiring to say the least. And then afterwards I had to help out with this. Let me put this back. I had to help out with putting this cabinet on the wall, which was a bit exhausting. Okay. We are proving by contradiction. Okay, so I'm trying to use ideas from the previous answer. So is it right? I think it might be right. Oh no, but it doesn't even say that it has to be an integer now. So if I just say 2n plus 3 and 2n minus 1 are both odd numbers. The product, actually now I'll make this an odd, because a product that is timesing together. Yes, sum is odd, product is times. So 2n plus 3, 2n plus 1, so that is equal to 4n squared plus 6n, because that's 2 and that's 8. 8n, because that's 6n and that's 2n, so that's 8n altogether, plus 3 is, so that's the answer. Now I need to prove that that is an odd number. So 4n squared plus 8n is even as it is sub by 2. Let's just like do a little bracketed thing so that 100% get the marks. So you can do this, and that's why it is even. 3 is odd, therefore an even plus and odd is always an odd. That's it. Let's have a look. Assume. Product of two odd numbers is even and can therefore be written in the form 2. For two odd numbers, 2n plus 1 and 2m plus 1. Did I have to use different letters? I don't think it really mattered, to be honest. But you can see that this is equals to 2k plus 1, right? K is k plus 1 is odd, which can oh, and I should have written and thus the product of two odd numbers is odd. Odd numbers is odd. So I got this. It's just that terminology I didn't get. With this one, this was 3 marks. That one was 3 marks. So with this one, yes, I'll feel free. But with this one, because I didn't clearly state the end statement, I'll just give myself the other 3. It's, I think I'm being quite harsh on myself, but maybe a teacher would be as well. So let's go. Let's do the next slide, next page. Prove by contradiction that if x is even, then x squared must be even. No, if you square anything, it's going to become an even regardless, I think. No, it won't, because 3 squared is 9. No, I'm stupid. What? I'm a bit tired. Okay, question 5. Question 5. Let me just wipe my glasses clean. Fx if x is then let x be 2n. So 2n. So 2n equals to x. So 2 times that. So x squared is the same as 2n squared. which equals to 4n squared. As 4n squared is divided by 2, it must be even. Therefore, by contradiction. So but am I contradicting this? I'm not certain if I'm actually contradicting because I'm proving this, I guess. So I'm not proving by contradicting, I'm just proving by proving. But anyway, I'll see if this is good enough answer, because this is how I would just prove it, but I'm not so sure if I'm proving it by contradicting it, if you get what I mean. Therefore, if x is even, then x squared must be even. If x is x squared be even. That's all. Assume x squared is not even. Oh, I know I had to do that wrong. Stupid me, stupid. Okay. I'm not gonna look any further into that. I'm gonna give myself an x. Not. I know I wasn't contradicting it. I did put this statement, which is good, which I needed, but now I wasn't contradicting. And I kind of figured out during the end, like, yeah, I don't think that's right because I'm not contradicting. So, let's redo this. Let if x, no, let x be odd, and 2n plus 1 is odd, so x equals to 2n plus 1. Therefore, x squared equals to 2n plus 1 squared, which equals to 2n plus 1, 2n plus 1, which equals to 4n squared plus 4n plus 1. And 4 squared plus 4n is even, so equal to, okay. Therefore, x squared equals to k plus 1. I'm not sure if this is the way to do it, but and odd and 2 and 2 make an odd and hello. So my sister came in, and that's why I had to mute for a second. But we're back. And to make an odd, because even an odd to make an odd, it I don't know, to be honest. Let's see what it says, because I'm not too certain about this. So x is not even. Integer x as x is even that x equals to 2 for some integer. Xn x squared is not even. Assume that x squared is not even. The first. Okay. As x is even, that since b squared can be as not. It must be even, not odd. Okay. Okay. So I've had the right idea. So this was right. I should have read a bit more into this. So this is good, but I have to say, assume x squared is not even. X squared is not even. Therefore, x squared Therefore, x squared equals to 2k plus 1 as 4n squared divided, which is as 2n squared can be written, can be 10 as 2 2n squared which is in the form 2k not 2k plus 1, then x squared must be even and not odd. And then x squared must be even and not odd. Yeah, no, this is a total red one. No. I'll still have to practice, so rethink this just to get in my head. So, basically what I've done wrong is I did not contradict. So I've had the idea, but I need to say that if x squared is not even, so it's odd, then it must be this. And the answer I got when it was even does not match when it should be odd. And basically that's it. So it's not odd. Which is, I don't know, which is basically what I've said here. But in this one I'm not contradicting, in this one I am. Even though it's basically the same idea. Prove by contradiction that there is an infinite number of multiples of 10. Contradiction. How would you contradict this? How would you say that yes, no, actually there are not infinite multiples of 10? Multiple. In all honesty, I don't have any clue how I would even think of doing this. Okay, let's, so for this one, let's just go back up. I think that was a 3 marker, wasn't it? I'll give myself 1 mark for that one. It's not the right idea, just not the right concept. And this guy, this is a 0. 3 as, yeah, it's just, I don't know. It's okay. Assume there are a finite number of multiples of 10s. Multiples of 10. 10. The largest being 10k. B, the largest being 10k for some k, 10k for some integer 10k. Now consider 10k plus 10 to be a multiple of 10. Okay. 10k multiple of 10. Of 10. 10k plus 10. 10k plus 10 equals to 10k plus 1. Is k an integer? Integer 10k must still be a multiple of 10. Of 10. Therefore 10k can not be the largest multiple of 10. Oh, that makes sense. 10k can be of 10. There are infinite number of multiples of 10. Therefore, number of multiples of 10. My brain hurts a bit. Okay. What to do? The only thing is, like, actually my head hurts a bit. Not being too dramatical. But yeah, I'm just feeling not the greatest, in all honesty. So, let's see how many questions are in the laws of indices and Surds one. I'll attempt the first few and see how far we go. I think I'll just attempt the first question just to give it a go. but I'll have to leave it for this just because I would rather do these questions when I'm a bit more energized and have a bit more focus. So let's just do one section. So now just question 1. Laws of indices and surds. Laws of indices and surds. Alright then. And easy question. Oh, an easy question. I need to write down easy questions. Questions. Well, I'm spot on. And let's do this. Question 1. Write down the value of so 81 to the power 1 over 4 means that we're rooting by 4, isn't it? I think because minus flips it, open the top, squares it, and that roots it. So let's read out 81. No, nope. Square root, nope. 4. How do I even say that? The 4th root of 81 is 3. Kind of assumed that. Well, that's good. So that's 3. I. Is that 8 to the power 2 over 3? I think so. 8 to the power 2 over 3. Which is so 8 squared and 3 and 2. Yeah, so it's basically just it's not you cancel it. Yeah, no, plus that's the way you do it. Which means that the 2. And lastly 5 to the power minus 2 equals 1 over 25. Okay. To be honest, I never liked proof like this. This is my cup of tea, kinda. I'll say that. I forgot to put the plus or minus sign here. Plus or minus. And why is that? Oh, I'm bloody dumb. I put 8, not 64. Which would have given me 4. No, yeah, so I'll still accept that. I won't accept this. So 2 out of 3. This is good. Yeah. Okay. Why not? Let's do another one. Simplify. Question 2. Simplify. So x3 plus x5 equals to, no, x3 times x5 equals to x8 a2 over a4. What's that equal to? Isn't that just 1 over a2? Yeah, I'm pretty sure, yeah. Then we have I, which is y 7 y to the power 5 over 7 times y to the power 1 over 7 all over y to the power 7, which equals to y to the power 6 over 7 all over y to the power 7, which equals to y to the power 3 over 7. That is x to the power 8, 1 over 2a squared, y 3 over 7. Amazing. 3 out of 3. Woohoo! I'm on a roll. I'm on a roll. Oh, I'll do this. Nice and easy. These are actually easy questions. The previous ones, I hate to admit, but I didn't find them too easy. Question 3. Write the following in the form a root b. I. And that is going to be root 2 plus root 8 equals to root 2 plus 2 root 2. That's 4 and 2, and then 4 cancels 2, which equals to 3 root 2 I 4 root 3 minus 4 root 3 minus root 12 plus 4 root 48. Yep, that equals to 4 root 3 minus 2 root 3 plus 48 divided by 3, 16 root 16, that is 4, so that is 8, no, 4 times 4, so that is 4, and then bracket 4 coming out from there, and then root 3, which turns into 2 root 3 plus 16 root 3 equaling to 18 root 3. And then lastly we have I, 2 root 2 to the power 3, 2 root 2 to the power 3, plus 3 root 2, plus 3 root 2 equals to well, I guess you can just put this in the calculator, 2, and then the power 3 is 2 root 2, and 2 to the power 3 is 8, so that's 16 root 2, 16 root 2 plus 3 root 2 equals to 19 root 2. That should do. 19 root 2, 18 root 3, 3 root 2. Get in the max. Yes. 3, good. Just what I like, just what I like. Rationalize the denominator. To be honest, there is quite a lot of these questions. Let's push through. 3 over root 2 times by root 2 over root 2 equals to 3 root 2 over 2. That's it, innit? In it. Yes. Multiple down. Yes. I know. Thank you. 2 out of 2. Rationalize the denominator here. Easy max. Yes. 3 plus root 5 times by 3 minus root 5 over 3 minus root 5 equals to, let's see the bottom first just to make sure it actually rationalizes. So 9 plus 3 root 5 minus 3 root 5 minus 5 over 6 minus 2 root 5 equals to 6 minus 2 root 5 over 4. These two cancel each other out, and then this can turn into 3 minus root 5 over 2. Get in. But I won't even read the explanation because I know how to do it. So in these ones I guess I'm saving time because there's no need to actually look through this for me, which is good. At least I've remembered something. Come on. Let's get all of these done so that I can, well, I've actually quite a few things to do after this, but I can do other things basically, other tiring things. Write that in the form that where area and constants to be found. So x squared, 6x squared plus 5x free. 6x squared plus 5x free over x4. So 6x squared over x4 plus 5x3 over x4 equals to 6 over x2 plus 5 over x which equals to 6x minus 2 plus 5x minus 1. 5x minus 1, correct? Getting 2 out of 2. Why is my watch beeping? Show that equals that equals that. It's just easy, just work it out, don't you? P plus 2 root 5. P plus 2 root 5. P minus 2 root 5. P minus 2 root 5 equals to, show that P squared plus minus 2 root 5p plus 2 root 5p minus 2 minus 4 root 25 which equals to p squared minus 4 5 which equals to, oh yeah, I just realized I've moved away from the camera. Oh no, what a god, the video quality, huh? 20. Okay. Amazing. So let's all of shown. Expand. And then that, simplify, and then yeah, so just worked out the question. Don't really know what I need to show about that. Well, that's 3 marks. Well, thank you. Thank you. Next question. Question 8. 28. Let's see how I'm doing with. Ah, that's alright. 28x squared 2x squared plus 3 all over This is intriguing. Huh. Very intriguing. So so that turns into seven. That turns into 7 times 4x squared bracket 2x squared plus 3 all over 7 x1 over 2. Just 7 can cancel out, which leaves James 8x4 plus 12x2 over x1 over 2, because you need to find I have an idea. What if we had x1 over 2 bracket 8x because by timesing you add, so x4, so that would be 8, and that would be 7 out of 8. 6 times that would be that, and then 12x 4 out of 3, and then you have x1 over 2, which you can cancel, leaving you with or you can do a similar thing with this one. Because if you just take the, instead of that one, you just make it so it's 4x, and you have x1 over 2, and this one is 3 over 4, and then you have 2x2 plus 3 all over x1 over 2. Then in 3 that still brings you to 4x3 over 2, no 3 over 4, 2x squared plus 3. I think don't know why have I done it out of 18. No, they both. So I've got this right. This is right, except the fact that this needs to be. That needs to be a 2. That needs to be a 2. And that would mean 8x 7 over 2, not 8, and 12x 3 over 2, not 4. Expand the brackets, original factor, and then simplify. That's a pain, but yeah. Well, I've gotten this far, so I would say I've got 2 out of the 3. Obviously not the 4th one, but I've still got it closely there. I was basically there. How many more questions? Range 9. 1. Not long left. 3 minus 2. 3 minus 2 root. Oh, question. Question 9. 3 minus 2 root 3 over 4 minus root 3 times by 4 plus root 3 over 4 plus 3 is to 16 minus 3 all over 12 plus 3 root 3 minus 12, no, 8 minus 8 root 3 minus 6 comes to 6 minus 5 root 3 all over 13. That should be it. 6 minus 5 root 3 all over 13. Amazing, amazing. 3 out of 3. And lastly, hey, made it. Okay, so x to the power 4 over 5 is equals to 90, no, 81. So that's first, so you can't root 81 5 times, definitely not, but I'll always give it a go. Yep, no, but 81 to the power 4 x over 5 equals to 4, 3, 0, 4, 6, 7, 2, 1, and shift answer, no, shift this, 5, shift answer equals to or just no, I'm doing it wrong because I need to square it 5 times and root it 4 times because I need to make this x, which brings me back to 81. How the hell? X power 4 equals to 4, 3, oh no. Let me just, it's like something with my eye. It's probably tired. Just give me a second. Oh. Okay. 3, 4, 8, 6, 7, 8, 4, 4, 0, 1. X equals to 2, 4, 3. Okay. So that's it. We're just going to check after I stab my eyes out. If it's correct. Correct, yes. Amazing. Look how smart we are. On the easy questions at least. And that's a green. So, that was quite successful. We have done quite a bit of the... So we've done laws and indices, laws of indices and surds. And we have done the easy one. We have proof, which is the one I load, which we have done previously, and proof by contradiction, which I've done now. So we've done these two, and some, as in the laws of indices and surds, have been a bit easier, and because I'm actually quite alright with them. But proof and proof by contradiction I'm not amazing at, so it's something I know I will have to work on, and I will do. But I'm happy with the results. So here's what we have done today. Proof by contradiction is the easy questions, and as you can see on the screen as well, we have done that. And as I said, there's room for improvement, and I haven't been amazing at it beforehand, and I know that's an area that I can work on. And on the other hand, laws of indices and surds, I have been and I am quite good at. I know these are the easy questions for the moment, but I do feel quite confident with them, so this is what I've done. And yeah, I'll file these away and go on from there. So, hope you enjoyed. It's been nearly 2 hours, 1.5 hours, around that time. It's been nice. Learned some, but I'll enjoy a bit of a rest after this. And next time, hopefully, I'll be able to do this at a time that's a bit more suitable for me to learn. It's not like I didn't learn anything, or that I haven't learned well, but yeah, basically, I did learn quite a bit from it. It's just that at some other points in time, I might be able to learn even better. So anyway, enough of me ranting. I'll see you in the next one then. Bye bye.